So next comes the least recently used algorithm, which means that so it will consider the past references. Among the past references, it will consider the least used page. Whichever page is least used or least referenced, then that particular page will be selected as a victim, and then it will be taken out from the frame or physical memory and then put into the backing store, so that the particular frame can be allocated to a newly referenced page. So that's why they say that this algorithm makes use of the past knowledge rather than the future. Optimal algorithm makes use of the future information, whereas the FIFO and LRU makes use of the past information. So in order to know which page has been or has not been referred for a long time in the past, so it will be associating a time of last use with every page. Okay. So time of last use is associated with every page, so that it will keep track of the amount of time it has not been used. So now consider the same reference strings and same number of frames. So for the first 3 pages, we will be having page fault. So 3 page faults. Then next comes the page 2. It is not in memory. So if you consider the frames 7, 0 and 1, sorry, pages 7, 0 and 1. So page 7 has not been used for, as of now page 7 is not used, okay, because 0 and 1 has recently arrived. So 7 has arrived in the past, okay. So now 7 is selected as a victim page, so it will be replaced by page 2. So now the pages are 2, 0 and 1. Now next consider the page 0. So 0 is again referred here, so it is already available in memory. So now we have to consider that 0 is referred again, okay. So consider next to their page, it is 3, not in memory. So if you consider 2, 0 and 1, 0 is now only referred, so it is its reference number of reference has increased. If you consider 1 and 2, so 1 has been referred long back. So 3 is replaced by, sorry, page number 1 is replaced by the newly requested page 3. So now the pages are 2, 0 and 3. Then again page 0 is referred. So again 0 gets another reference. So among 2 and 3, among 0, 2, 0 and 3, so 2 is considered as the old reference, okay. So if you consider the next reference, it is to the page 4. So among 2, 0 and 3, 0 is now only referred, 3 before 0. So if you consider 2, it is the one which has not been referred for long time. Comparing to 0 and 3, 2 has not been referred. So it is replaced by page 4. Now consider page number 2. Next reference is page 2. It is not in memory. So considering 4, 0 and 3, 3 is not referred. Okay. See, 4 is currently referred. Previously referred page is 4. Then previous to that 0 is referred. Then only after, before that 3 is referred. So 3 is removed. And then it is replaced by 2. So now the pages are 4, 0 and 2. Then now consider the page 3. It is not in memory. So if you page fault occurs, so at this point of time, if you consider the pages 4, 0 and 2, 2 is referred recently, 4 previous to that. Then if you consider 0, so it is referred. So this is the page which is referred long back. So now this page 0 is replaced by page 3. So now the pages are 4, 3, 2. Again reference for page 0 comes. So in this case again a page fault occurs. So here it considers the page 4, 3 and 2. Among these 3 pages, 3 has been referred uh, recently, then before the 2, then if you consider the page 4, it is referred earlier, that is or it has not been referred for long time. So 4 is replaced by 0. So now the pages are 0, 3 and 2. The next reference is to the page 3. So it is already available. The next reference is 2. Again it is also available in the memory. The next reference is 1. So now if you consider the pages, so for reference 1, a page fault occurs. So in this case, it has to find a victim to be replaced. So in this case, the pages are 0, 3 and 2 in the frames. So among these 3 pages, we have referred to recently, then prior to that 3 is referred. So 0 is not referred for long time. Okay. So now 0 will be replaced by 1. Okay. So now the pages are 1, 3 and 2. So if you consider page 2, so it is already available. So then next reference is 0. It is not there. So a page fault occurs. Now again victims should be selected. So among pages 1, 3 and 2, if you consider 2, it is recently referred. Then 1 is also recently referred. If you consider 3, it is referred long back. So 3 is replaced by 0. The next reference is to the page 1. So it is already available. So no fault occurs. Then next one is page 7. So it is not in memory. So now again page fault occurs. So again victim page need to be selected among the pages 1, 0 and 2. So considering these 3 pages, 1 is recently referred, then previous to that 0. So if you consider 2, it has not been referred long back. That is when you can among these 3 pages, 2 is not referred recently. So 2 is selected as victim and then it is replaced by page 7. So now the pages are 1, 0 and 7. So the next reference to the page is 0. It is already there. The next one is 1. Again it is also there. So if you consider, assume that there is another page number 5. Okay. A request for page number 5 arrives. So now again it is not there. So what happens? Another page fault occurs. In this case, if you consider 1, 0 and 7, 1 recently referred, 0 again is also referred. So only back to 0 and 1, 7 is referred. So 7 is the least recently used page. Recently used, okay, least recently used. Whichever page is not used recently, then that particular page is selected as a victim. So if among 1, 0 and 7, 7 is the least recently used page. So 7 is replaced by 5. So in this case, the pages will be 1, 0 and 5. So if you consider the number of page faults, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 page faults has occurred. So if you consider FIFO and LRU, so in LRU 15 page faults. LRU has resulted in 15 page faults for the same reference name. Optimal it is 9. LRU 12 page faults. Okay. So comparing LRU with optimal, LRU and FIFO, LRU has produced less page faults. In the next video, I will demonstrate you various disk scheduling